Alright, 7.1b, linear and nonlinear systems of equations. Now this lesson is going to put your understanding of systems to the test, because now you have to construct your own system. Alright, so a total of $25,000 is invested in two funds, paying 7%, 4% simple interest. The yearly interest is $1,405. How much is invested at each rate? Okay, how much is invested at each rate is the main question. Okay, so X, we'll say, is the amount invested at 7%. We'll say Y is the amount invested at 4%. All right, the 7% fund and the 4% fund. Okay. So I know if I add these two amounts together, I'm investing $25,000 total. So those should add up to $25,000. All right, now here's the next part that tends to confuse students the most. All right, how much did I invest? All right, we got 4% here, 7% here. The total interest is $1,045. All right, so I'm going to have to use the information that I have here and here together. Okay, so I invest a certain amount into the 7% fund. All right, and I'm making 7% off of that amount. So multiply it by 0.07. I'm investing a certain amount, Y amount, into the 4% fund. So I'm making 4% off of that. All right, and the interest of those combined is $1,405. All right, so there's your system. That's the most difficult part. Once you have that, it should be easy to solve it. Okay, now I'm gonna isolate. I'll isolate Y. So Y is equal to 25,000 minus X, and I'll substitute it in for Y here. So 0.07X plus 0.04 times 25,000 minus X is equal to 1,405. All right, and I'll distribute here. So I'll get 0.07X plus 1,000 minus 0.04X is equal to 1,405. All right, combine these two, I get 0.03x plus 1,000 equals 1,405. And I get 0.03x is equal to 405. All right, now I divide by 0.03. And I get x is equal to 13,500. All right, that's a key value. Now I want to figure out y, so I just plug it in up here. And I get y is equal to 25,000 minus 13,500. And y is equal to 11,500. All right, those are my two answers. So I could box these. I'll say 13,500 is invested in the 7% fund. And 11,500 at 4%. Okay, let's do another example. All right, example 2, break-even analysis. Very important concept to understand for entrepreneurs. A small business has an initial investment of $6,000. The unit cost of the product is $23.20, and the selling price is $32.50. How many units must be sold to break even? All right, what is breaking even exactly? It's when the cost is equal to the revenue. All right, another way to view breaking even is when the profit, which is equal to the revenue minus the cost, is 0. In other words, R minus C equals 0. Okay, revenue is your sales. Okay, and when you sell something, that doesn't mean that's profit. You paid a certain amount for that item before you sold it. All right, so the profit is always essentially what your sales were minus the cost. Then you get your profit. All right, so starting off with this problem here, we have the cost. What is the cost? Well, each unit was $23.20. And we sold a certain amount of units, we'll call that X. And the initial investment was $6,000, so we have to add on $6,000 to the cost. And then revenue. Well, what's revenue? Selling each unit for $32.50. All right, and X represents the number of units. All right, make sure you use the same variable. Okay. And now, in order to figure out break even though these variables aren't the same, they are the same when you're breaking even. They're equal to each other. So you set C equal to R. And you have 2320 plus 6,000 is equal to 3250. Alright, 930x, then we divide by 930, and x is equal to 645.16. Alright, and if you're trying to get the number of units, you always round up. So 646 units. Alright, since we're working in the real world now, we have to sell more than 645 units if we want to break even. We have to sell above that because we have the 0.16 here. So you round up to the next whole number, 646 units. All right, that's all there is to that. Let's do another example. All right, from 1996 to 2003, the population of City A was increasing at a faster rate than was the population of City B. Models that approximate the two populations. All right, we got these two models here for the populations of the two cities, where T represents the number of years since 1996. According to these two models, when would you expect the populations of these two cities to be equal? All right, well, how do I know how long it's going to take for the populations to be equal? You just set the population equations for the two cities equal to each other. So you have 4,973.3 plus 95t is equal to 5,118 plus 41.4t. All right, let's subtract here. All right, those cancel out. I get 4,973.3 plus 53.6t is equal to 5,118. All right, then I'll subtract 4,973.3. 53.6t is equal to 144.7. Divide by 53.6. And t is equal to 2.7. And it's going to be years in this case. Done. All right, if you have any questions, please make sure to ask. Begin the assignment.